Chapter 5 in our geometry textbook is all about quadrilaterals. And the first type of quadrilaterals, and our biggest focus in this chapter, is going to be parallelograms. Section 5.1 is entitled Parallelograms, and we define a parallelogram as a quadrilateral with opposite sides that are parallel. So when I draw a parallelogram, as neatly as I can, we just have to know that this side is parallel to this side because they're opposites, and this side is parallel to this side over here. And a quick note, parallel lines means same side interior angles are supplementary. So if we look at sample 1 over here on the right, simple problem 1 says the measure of angle 1 is x plus 20, and angle 2 is 2x plus 10. And what we notice about these two is they're same side interiors on two parallel lines that are cut by a transversal. Look here, like if I had two parallel lines over here cut by a transversal, these two angles would be supplementary. So we're going to say 2x plus 10 plus x plus 20 equals 180 degrees. So we have 3x plus 30 equals 180. So x, well, we'll say 3x equals 150, and x is 50. Okay. Now our properties of parallelograms. Property number 1 says opposite sides of a parallelogram are congruent. Now we could do a proof of this by drawing a diagonal and proving that we had two congruent triangles, which we'll actually talk about later. But opposite sides of parallelogram are congruent, which means this side and this side are not only parallel, but they're the same length. And these two sides are the same length. So when we look over at sample problem 2, it says AC is 3x minus 5, AB is 5x, and BD is 2x plus 10. Now here, we have more information than we need. We don't need the 5x because all we really need are the opposite sides, which we know are congruent. So we say 3x minus 5 equals 2x plus 10. We solve for x, and we get x equals 15. Property number 2 says opposite angles of a parallelogram are congruent. That means this angle and this angle are the same length, or the same measure, sorry, and these two angles are the same measure. So when we look at sample problem 3 here, we have angle 1 is 3x minus 30, or minus 40. Angle 2 is 3x minus 20. And angle 3 is 2x. Now we could say that these two angles add up to 180 and solve that way. But what we'll do here is I'm just going to say that opposite angles are congruent. Make it a little easier. 3x minus 40 equals 2x. Subtract 2x from both sides and add 40. We get x is 40 degrees. And number 3 says, the third property here, diagonals of a parallelogram bisect each other. This is a little bit more complicated. What this says is if we draw the two diagonals of a parallelogram, they're not congruent. This one's split in half by this one, and this one is split in half by this one. That's when we say they bisect each other. That means they split each other in half. So looking over here at sample problem 4, when we have Fy is 3p minus 8, 3p minus 8, and Gy is p plus 7, and Yo is 2p plus 2, and GR is 34. This whole length is 34, which means since it's split in half, it's 17 and 17. Now we have a couple options here. We have p plus 7 here is equal to 17, or we could say 3p minus 8 equals 2p plus 2, because these two things are equal, and these two things are equal. So I'm just going to solve it with the easier of the two, and get p equals 10. Okay, now let me just make sure this one worked out nice. 3p minus 8 equals 2p plus 2. The way we look at this here, we say subtract 2p, add 8, Yep, we get the same answer either way, so that means we're good to go. And that's the end.